Welcome back. In today's tutorial, we will learn how to design your own version of Candy Crush in Godot. If you haven't played this genre of game, so basically you have a game grid where you are allowed to do a swap motion to change the tiles. The tiles that match 3 or more pattern are destroyed and thus yielding you a score. We will implement all the functionality of a basic version of Candy Crush. We already have the project setup done. The game contains only 2 scenes. The starting scene is the game scene that contains a single parent node and a grid container node. We will set an initial position and size for the grid container. The game root node contains the game script attached to it. In this game script, we define few constants like the grid size rows and columns and also create variables to store the game tiles and selected tile. Once the game scene is ready, we create the board for our game, which then initiates individual tiles for our 8x8 grid. The tile scene contains a button root node along with a texture rectangle and a color rectangle node. Tile root node has a predefined layout set for its minimum size. The texture rectangle contains the Godot's default icon sprite that we will using for the game. We also set the transformation for this node. Then we have a color rectangle which has a transparent white color configured. This node will be used to highlight the currently selected node in the game grid. Also, we set few layout options to control the size of this texture. In the tile script, we have few variables to specify which row and column in the grid does this tile is placed, also a tile type variable to specify the type of color. You can also customize this to use different sprites, but in our case we will use different color modulations to control different types of tiles. We will define a signal on the tile scene that will be used to indicate when a tile has been selected. When we emit the signal, we also want to pass the current selected tile along with the signal. This way, we can get reference of the currently selected tile in the game scene. We also want to turn on the color rect when a tile is selected. This will be done with the highlight method. When the tile emits the click signal, we want to take action on the game scene. For this we will create a callable and attach the signal. This click signal event will pass the tile object as input parameter. In the tile clicked, at first we need to check if there is no tile is selected. In this scenario, we will update the selected variable with the tile and turn on the highlight. In case if a tile is already selected, then we have 3 different scenarios to take into account. The first scenario would be if user selected the already selected tile. In this case, we don't want to take any action, so we will unselect the tile and revert the highlight. In the second scenario, we want to check whether the user has selected a tile that is adjacent to the selected tile. In this case, we have a possibility of swapping the tile. And lastly, if user doesn't select neighboring tile, then we can't do a swap. So we will reset the selected tile and turn off the highlight for the last selected tile. This case is similar to the first scenario. The logic for checking adjacency is simple. We just need to check if the cell A is placed to either on top, bottom, left, or right of the cell B. This can be done by checking the row and column coordinates of both the tiles. In case the tile is adjacent, we need to try swapping the cell and see if there are any matches that can found to break the tiles in the game. We will handle this logic in a different method. The swap function will help us to swap two tiles in the board. The logic for this is quite straightforward. We take the tile types of each tiles and swap it between one another. Also, in order to make the swap more interactive to the user, we will add a small animation using tweens. We will create a tween to slightly modify the scale of each tiles. We want to do this for both the tiles. Since we already have a method to set the tile types and update the visualization, we will make use of it to swap the tiles. The tile scene doesn't update the colors, unless we specifically call the modulate on the tile to change it. For this, we will create a change_type method on the tile that will handle the change. Now our swap is working perfectly. Next, let us continue with our logic in try-swap method. Here we want to find matches of different tiles that are closer together in rows and columns. For this, we will make use of this function called find_matches. If we don't find any matches from this method, that means there was nothing to break. So we simply revert back the state of board by swapping the selected two tiles. In case we find matches, then we need to remove the matches and refill the board. While refilling, there can be a situation where the board gets more matches. So we will try to continuously evaluate for more matches and try to remove and refill. This will be repeated until our game board doesn't have any more matching tiles. The find matches will first check horizontally to find tiles that continuously match for 3 or more counts. These are tracked in the remove array. Similar operation is done vertically next, but by going through columns. We also need to handle the case when there are elements common across both the array. So we try to deduplicate here before returning the final set of matches that needs to be removed. Remove matches logic is quite simple. We need to go through each tile positions and then update the type of the tile to -1 to indicate that tiles has been unset or deleted in our case. In the refill method, we first move down the tiles, thereby filling the empty tile position. Then we need to update the tile types for the unset tiles. We do this by going through each column and then first finding the stack of undelete tile types. These tile types are then set to the last rows. We also add a small animation to the tile types where we create the new tiles. For this, we had tracked the newly added tiles in the new underscore tiles array. Then by using a simple tween animation, we scale up the tile, thereby adding a pop animation. There was a small indentation issue in our code that messed up with our logic on removing the tiles. If you had made the same mistake, please do correct it here. Now with the minor bugs resolved, we now have the game working. We will also add one more method to ensure that when our game initially starts, we don't have any matching tiles already present in the grid. Next, we will be creating a simple UI for our game. We will create labels to track the time and score of the game. The time label will be updated based on the current value of a timer, while the score label updates based on the number of matches we find from the swap. In addition, we will create a simple menu for the game start and end. You are free to customize this further based on your creativity, but for the purpose of completing the tutorial, I'm going to create a simple version of the GUI. Hooray! You finally made it to the end of the video and we have a working clone of Candy Crush. You are free to explore this further. Add game levels, add unique tile sprites, add sound effects and much more. Make sure to subscribe to the channel for brand new game tutorials. Thank you.